In this section, we will learn about the remaining of the concepts in OOP, especially the major one, the polymorphism, and other two relevant one, the abstraction and the special methods where we can do the operator overloading. I would like to say I have an opinion here. These concepts are much easier to be administrated, and its power can be very visible in languages like C++ and Java. I believe like the sense in a language like Python is a bit different, maybe a bit less than the other programming languages, but we still can get a good deal of the OOP concepts here in Python. So let's see, what do we mean by polymorphism. The word polymorphism means many forms. What does it mean? Look to this function here, the length function. When we pass for it this list, it gives us the length. If we pass this tuple of items, it gives us the length. If we pass it as a string, it give us a length. Now, what is interesting here? The same length function is receiving different types of objects, and still it can answer for us what is the length of the current object. The reason behind that, as we will know by the end of this section, that every object from these guys has internally a length function. So this length function is actually calling the internal length function. Now that looks like a straightforward one. Let's see another very interesting case. The plus and asterisk here. When you see 2 plus 3 times 4, we know from math that this is going to do the normal math operations. But when we see something like most plus sad times 4, we observe here we are applying a plus and multiplication over strings. Now this is so weird. So the same operators are now doing another functionalities. This is what we mean by the polymorphism. It is the ability to use functions and methods and operators, objects with different types and potentially behaving differently. So here the 2 plus 3 times 4 is going to compute math formula, but sad times 4 is going to repeat sad 4 times, and then most will be concatenated to all of them. So now the behavior here is a bit different. We call that operator overloading, by the way. Like you are overloading these operators to do specific different behavior. Behind the scene, as we will know, the plus and the multiplication are actually specific functions that are defined in the integer class or the string class doing a specific operation. So again, polymorphism means many forms. As you see, different types of things could behave in a different way while sending to different functions. Let's try to administrate that more. But let's first learn about the duck typing thing. I would like you to take a minute to read this code and think, what does it mean? When you look to this code here, we have a class named car, person, and both of them share the same method, getName, regardless of the behavior now. Both of them had the same method. And we have class home that doesn't have this method. Now thinking about the class process, it takes some object and it doesn't know what is that object. And then all what it needs is calling the getName. This in Python we call it duck typing. We don't care that this guy here, is it car or is it person. All what we care that it has a getName method that is expected to do something we agreed on it. If you pass to this function car, is going to get its name. If you pass the person, is going to get its name. But do not pass home because it doesn't have the getName function. So by Python and the duck typing, we mean all what we care about is, does it have the method or not? Does it make the sound of the duck or not? If it makes the sound of the duck, then it's just a duck. That's simple. This is the philosophy in Python. So you can think now the process function, very similar to the length function here, is receiving different objects and is going to do some computations here, and all what it needs is the functions that we need exist with the expected parameters to do for us something we agreed on it. The length function will take some object and return the length of it. That's all. Observe here, we don't need any kind of inheritance to activate the polymorphism. If you are coming from C++, you will notice that this kind of coding will not be okay, for example, because we don't have duck typing in the Python. in C++ or Java. You will need that, you need to know that this object, is it person, is it car, is it something like a global object for them, a global parent or not. But in Python, we care only, does it have the object that I need or not? Let's see more practical example that involve inheritance this time, although inheritance isn't a must also. We have the class shape, which is just to receive a name, and it seems that we have an area function. Observe that we don't know how to compute an area of a shape. We need to know if it's a rectangle or a circle or whatever. That's why we're here. If it happened that someone created an object from the shape, we're going to raise this exception, not implemented error, exactly this way. Now, the rectangle class is going to take 2 extra parameters, width and height, and we'll use it to compute the area of the rectangle. The circle class has a radius parameter and is going to do for us the area computation. The inheritance here made sense because we needed this name to be common with that guy. So far we have 3 classes and all of them has the area method. Now let's say that we have a class that is going some editor of different shapes. So it has here list of shapes, and the process function is going to print the shape name and the shape area and accumulate for us all the shape areas we have. Now here in the editor we append the rectangle, another circle, another rectangle, and we can now call the editor.process. Observe here the process isn't aware what are exactly the shapes objects here. It doesn't care if this is a rectangle, it doesn't care if this is a circle, it doesn't care. It only cares that this guy can provide me with .name and .area. If we can do that, then the process function is a polymorphic function. Why? Because it is dealing with the objects that could be of many forms, of many data types, and still can behave in a proper way as an overall functionality. So this is mainly the concept of polymorphism. Again, the concept isn't very clear as it would be clear in a language like C++, but I hope you got the idea. Let's see another interesting thing. The class shape here is a bit modified. It has a print function that prints the name and area. But observe the following. The shape class doesn't have the .area function. So if we try to create the shape and call print, we will fail in the area because it doesn't have this area thing. But observe the following. The class rectangle here has an area method. So an area property. So when we actually create an object and call print, remember that this self is referring to the rectangle. So area here is actually will refer to this guy. So everything is okay. I hope you at this moment already, from what we learned, can understand how this code is already working. The concept that I would like to teach you here is something very important in software engineering, especially frameworks. We call it inverse of control. There is a normal flow and there is a flow that is inversed. What does it mean? In practice, when this class rectangle is going to extend from the shape class, then the rectangle knows everything about the shape. But could it be that the shape is knowing something about the rectangle? This is weird. This is now the inverse of the flow of that. So now the interesting thing here, the shape know that my son is going to have this area function that I don't have it at the moment, or I am not going to implement it. So this is very interesting. Let's see another example here. I gave you this good example before in one of the quizzes. We have a graph algorithm. You will study algorithms in algorithms course, and the class has a run function that has 3 steps. The first and third step are general, so they are implemented here. However, the second step here must be supported from the child. So the graph algorithm run function is going to evaluate every step. But one of the steps must be supported from someone who is down there. So actually this is like the opposite of the flow. The graph algorithm is intentionally waiting and expecting and arranging something based on the child class here. So this is a nice concept to know about it, because in the future when you study frameworks like web development frameworks, you will notice the idea of inverse of control is visible in different frameworks. So the moral of it is that in normal flow, the child class know about the parent class exactly differently, but in the inverse of control, you as a parent class is actually doing the inverse of thing. You have a flow of step 1, step 2, step 3, and at some point you are giving the control to the child to make something, then it comes back to you again. That's why we call it inverse of control. That's all about today for the inheritance, and I would like now to refer to something that is a bit relevant and very important. You will notice in the industry that we tell the people a lot, composition is preferred over inheritance. I hope through the last section you realize that the inheritance could be very problematic and very confusing, especially multiple inheritance. In the industry, people in general avoid inheritance. So what we do is actually the composition way over the inheritance. So if we can do composition, like for example, the car has an engine, find your way to re-express the system in terms of composition, in terms of a class that has an object from another class. This will avoid you what we call the combination hell, that sometimes you are combining classes that has a lot of functionalities that are irrelevant and causing a lot of problems. In programming languages like C++, you will notice the sense of composition and polymorphism very strongly. But again, as Python by definition, due to the duck typing philosophy, is actually polymorphism by implementation. It is polymorphism. So you then actually feel a lot. Why do you need to connect the composition idea with the polymorphism? In language like C++ and Java, this is going to be very visible. So that's the way to go in the industry. If you have a problem that should be modeled as an inheritance, give a little thinking. Can we rearrange it as a composition and it's still very good direction or not? Later in the future, you should study a design pattern course in a deeper way. In this course, I tried to mention some different design patterns from a time to another. You will notice that different design patterns can help us make the switch from inheritance to composition. For a while, you might think about several inheritance problem. How could that be transformed to a composition? But with the study of different design patterns, you will start to understand how can we do that from time to time. There is a penalty for switching from inheritance to composition, which is typically you have to write more code to do the delegations. What do you mean by delegation? When you receive a call, you are now just calling your internal class. So let's say you would like to implement, for example, implement maybe an employee. In an inheritance sense, you will have the employee extending from person. But in a composition way, you will create a class for an employee and have an object inside it from person. And then for requests to set and get and do something with the person, you delegate the calls to the composed object, to the object inside you. So overall, you might need to write a little more code, but with the design patterns, different design patterns, you will notice that this is a bit doable. So think about that in practice in real projects. That's all.